Dear students, I am Lakshmi Hebbar here. We are now continuing electronic interpretation of orienting influence of orthopara directing groups in this fourth session in aromatic hydrocarbon chapter. Here we need to discuss about the orthopara directing groups such as methyl group, chloro group, amino group and hydroxy groups which are mentioned in the syllabus. Hope that you all are clear with the meta-directing groups which is discussed in the previous session and practiced to write the resonance structures of compounds containing those meta-directing groups. And in the last session we also seen that the groups like methyl, chloro, amino and hydroxy which are known as electron donating groups always direct or orient the second substituent group to the ortho and para position, and hence these are called as orthopara directing or orthopara orienting groups, and also they are known as activating groups. For this we had taken the example of phenol where hydroxy group which is electron donating group present on the benzene ring which is nitrated with the help of nitrating mixture, that is nitric acid and sulfuric acid concentrated. We end up with the products which is the mixture of orthonitrophenol and paranitrophenol. That means OH group directs the nitro group, that is NO2 group, to the ortho position and para position. Now the reason for getting these products can be explained on the basis of electronic effects, and that is nothing but electronic interpretation for the ortho and para directing influence. Now again we take up the example of phenol where OH group is present on the benzene ring and this OH group is electron donating group. Now if we examine electronic structure of OH group, the oxygen atom which is directly linked to the ring carbon atom and is known as key atom is carrying 2 number of unshared pair of electrons. Similarly, if we take the example of another electron donating group, that is chloro group, where chlorine atom is key atom and carries 3 pairs of lone pairs of electron. Similarly, amino group which is having 1 pair of lone pair of electron on the key atom, that is nitrogen atom. Now these lone pair of electrons are conjugated with the pi electrons of the ring, and hence lone pair of electrons are shifted to this position and this carbon atom gets pentavalent, and hence to make it tetravalent this pi bonding electrons are moving towards the ortho position, that is ortho carbon atom in the ring. That is known as delocalization. It occurs due to the resonance. As a result of this, we get this structure where oxygen atom gets positive charge by losing the electrons and ortho carbon atom gets negative charge by gaining the electron. Now again this negative charge is conjugated with this double bond and delocalization takes place to give negative charge in the para position, and again delocalization takes place to give the negative charge on the ortho position. So we can have 3 resonating structures for the phenol due to the delocalization of lone pair of electrons present on the key atom, and for this we can write the resonance hybrid like this. So here oxygen atom has got partially positive charge and this bond is forming, and these ring double bonds are shifting from one place to another place, that is partial double bonds are present all over the ring, and ortho and para positions are having partial negative charge. Now this type of delocalization of lone pair of electrons present in the key atom towards the phenyl ring is known as plus R effect, that is plus resonance effect, or you can say that hydroxy group is donating the electron to the ring by resonance effect, and this makes the ring electron rich due to the plus R effect, so that the ring will be activated towards the electrophilic substitution. But you can observe this OH group is also exhibiting inductive effect on the phenyl ring, that is, it is withdrawing electrons from the phenyl ring by inductive effect due to the higher electronegativity of oxygen atom. But it is of very less quantity. Naturally, plus R overcomes minus I effect because minus I is very small compared to plus R, and hence the ring is activated towards the electrophilic attack. However, this relative increase of electron density is greater at ortho and para position, which is indicated by negative charge, and not meta position. Meta position is neutral. That is why if it finds any species carrying the positive charge, that is electrophile, nearby it, it attracts electrophile towards the ortho and para positions and not to the meta position, and hence in the dye substitution electrophile enter into the ortho and para positions to give the mixture of ortho and para dye substituted compound. Now we can say that the polar characteristics of all the electron donating groups are minus I and plus R type, which we had seen in the case of hydroxy groups. But it is not the same in the case of methyl group, which has plus I instead of minus I effect. And one more thing, chloro group, which have strong plus E effect, that is electromeric effect, in addition to these two effects. Now these can be cleared if we write the resonance structures of substituted benzene derivatives. So for this we take up the example of aniline first. So you know that nitrogen, the key atom, has got one pair of lone pair of electron and conjugated with the ring double bond, and hence delocalization takes place due to plus R effect. And same as in the case of phenol, this amino group also exhibiting minus I effect, which is of very little amount. So naturally plus R effect overcomes the minus I effect, that is amino group is pumping the electrons towards the phenyl ring and give the resonance hybrid having this structure, where ortho and para positions are relatively rich in electron density rather than the meta position, because meta position is not involved in the resonance. So electrophile coming near to the aniline will attack on the ortho and para positions to give the ortho and para substituted compounds. But in the case of toluene, the methyl group present on the benzene ring is not having any lone pair of electrons on the key atom, that is carbon atom. We know that carbon atom is not having any lone pair of electrons, yet it is ortho-para director and also it is ring activator. So that can be explained by another type of electronic effect, that is hyperconjugation effect. Now this methyl group, apart from having plus I effect, that is electron donating by inductive effect, when it attached to the conjugated system like this, it exhibits a special type of electronic effect known as hyperconjugation effect. Here the sigma electrons of CH bond are conjugated, or they interact with the pi electrons of this ring double bond. So what happens? Again delocalization of sigma electrons takes place here, and the ortho position will get the negative charge and hydrogen atom gets positive charge. So that negative charge on the ortho position will be delocalized to para position and another ortho position in these hyperconjugative structures. And for this we can write the hybrid structure like this, where one of the hydrogen in the methyl group gets partial positive charge and this bond is breaking and this double bond is forming, and the ring double bonds are partial double bonds and they are delocalizing. So by this you can say that the electrons are pumped from methyl group to phenyl ring due to the hyperconjugation effect. So both electron donating inductive effect and hyperconjugation effect makes the ring electron rich, and hence the ring is activated towards the electrophile. This enhancement of electrons density is relatively more at ortho and para positions rather than meta position. So when it finds the electrophile, the substitution takes place at ortho and para position to give the ortho substituted toluene and para substituted toluene. So methyl group activates the ring and also ortho para directing group. Now coming to the next example, that is chlorobenzene, where chlorine is attached to the benzene ring, but this is having somewhat anomalous behavior. That is, it exerts strong electron withdrawing inductive effect, that is -I effect, due to the highest electronegativity of chlorine atom. So inductive effect makes the ring electron deficient and hence deactivation towards the electrophilic substitution occurs. And you can observe here there are 3 pairs of unshared electrons present on the chlorine atom, which are conjugated with the 5 electrons of the ring, and hence again delocalization takes place, which produces negative charge on the ortho position and positive charge on the chlorine atom. So this effect is known as +R effect. But according to the scientist in gold, this +R effect of chlorine is too small. It is negligible. So it is of no significance. But when the attacking reagent, say an electrophile E+, is nearing to the chlorobenzene, there will be existence of a temporary electronic effect called as electromeric effect, and hence ortho para positions are raised in electron density above that of meta position. So this happens in the presence of attacking reagent. That temporary effect is known as electromeric effect. So E+ effect will be there along with the weak +R effect. So overall effect is decrease in the electron density as compared to benzene ring. It happens in the chlorobenzene. But partial negative charge are present on the ortho para position. So if at all electrophilic substitution takes place, that happens at ortho para position rather than meta position, which is neutral. So you can say that chloro group is weakly deactivating at it is ortho para directing. So this is the anomalous behavior of chlorobenzene. So till now we had discussed the cases of phenol, aniline, where +R effect is very much stronger and hence ring activation takes place, and also electrophilic substitution occurs at ortho and para position. And next, in the case of toluene, where hyperconjugation effect is responsible for ortho para orientation, and in the case of chlorobenzene, it is occurring due to the temporary effect known as electromeric effect. Due to the existence of strong electron withdrawing inductive effect, the ring is deactivated towards the electrophilic substitution. So here it is very important that you should be able to write the resonance structures for each compound and hence explain the orienting effect depending on the different types of electronic effects. For this and also for the meta orienting groups, you can refer these books. Now we will end the session and meet in the next session with the topic resonating structures of polynuclear hydrocarbons.